Number 25. Nitrogen monoxide reacts with chlorine according to this equation. So we have 2 NO gas plus Cl2 gas yields 2 NOCl gas. The following initial rates of reaction have been observed for certain reactant concentrations. And then they gave us this beautiful table here. Now in this table we have different concentrations of NO, nitrogen monoxide, with different concentrations of chlorine gas, so Cl2, and with these different concentrations, a rate of reaction was produced. Now the question here says, what is the rate law that describes the rate's dependence on the concentration of NO and Cl2? And then we have to find out what's the rate constant, and then what are the orders with respect to each reactant. Okay, so the first thing is they want us to find a rate law. Now, this is pretty standard, especially if they're asking for a rate law and they give you some type of chart. Now, when they give you a chart and they're asking for the rate law, they're secretly asking for something else. What they're really asking for is what are the orders of the reaction. We have to find the orders. Well, what does that really mean? Well, if we look at a generalized rate law, which is this right here, right? Let's just bring it down. We can see that any type of rate law is always rate equals K. K is the rate constant, times by the brackets means concentration, so molarity. So it's always times by the molarities of the reactants raised to their orders. Now let's just put this general formula up here. And let's try to make one that is specific for our needs. Now, in this case, our rate law, right? And maybe what I'll say is this is the general rate law. So in order to make our rate law has to be some type of rate equals K times the concentration of the reactants. Now, in this case, we have 2 reactants according to the balance equation, and they do list out those reactants in the chart, right? NO is a reactant. It's on the left side. Here's the concentration for NO. Cl2 is a reactant, and here's the concentrations for the Cl2. So I have 2 reactants. So I need 2 brackets. And in this case, we have NO and the Cl2. Now, if you have multiple reactants, just know that these are always multiplied together. So if you have multiple reactants, it's always multiplied, not added, okay? But now the thing is that as many reactants as you have that many orders. So now here comes a little bit of a challenge, but don't worry, we got this, right? Because do we know the order for NO? The idea here is that if they give you a chart, we generalize that this balanced equation that they give us is an overall reaction. And if it is an overall reaction and not something called an elementary step, we cannot assume that since this NO is a coefficient of 2, that this is going to be squared. And we can't generalize that since there's only one Cl2 here, that this is going to be raised to the first. That's why when I write my generalized rate law, I don't say that this is just as simple as putting it to the coefficients, because they can give you data that completely, does not go with the coefficients that they give you. So make a note here that whenever they give you a chart, we have to find those orders. So I don't know them now, so I'm just going to label them as, any variable. Let's start off with X, right? So NO would be raised to the X. But now, Cl2, if I label this as X, that means that these 2 would be the same order. I don't know that, right? One could be 2, one could be 1. So the thing here is that I can't label it as the same variable. I'm going to choose a different letter. It doesn't matter what letters you choose, A, B, C, D, whatever. I'll just choose X, Y. And now here is the generalized rate law. We need to find those values because once we find them out, we could plug them in, and that is your rate law. That would be the answer to the first part. When you write a rate law, you do not write the rate or the K values. You just write the orders. That's the only numbers that you include. All right? So now here's the thing. Going back to algebra, right? Oh, shoot. All the time that we've been doing algebra, we've only been able to solve for one variable at a time, right? The answer is always x equals a number, or the answer is always y equals some number. But the answer always is never going to be x and y, right? We want to single out these two variables. So that's the plan here. So the first step is we need to pick which one we're going to solve for first. We can't solve for both orders at the same time. We have to do one at a time. So it doesn't matter. You choose. I guess we'll go from left to right. So I want to solve for the order that goes with NO, aka nitrogen monoxide. I want to solve for this variable. So if that's the case, if you want to solve for x, that means you have to get rid of the y, right? Because I only want my final answer to be x equals. So in this case, if you want to get rid of y, we have to make a relationship between two trials to get rid of the y value. So in this case, we're going to just say we're going to get rid of the whole Cl2. And that's how we're going to get rid of the y. Now, this is always just making ratios, right? There are 3 trials here, or you could call them experiments. So in one experiment, we have the same concentrations for NO and Cl2, and it produced out a rate. In the second experiment, we changed the rates, and we got out we changed the concentrations, 1 molarity for NO, 0.5 for Cl2, and we got a different rate. And then as here, we changed it again and we got out a different rate. So I'm going to say that the first line is trial 1. The second line is trial 2. And the third line is trial 3. I know that I'm like going, a little bit. Maybe what I'll do is I'll maybe bring this somewhere else. I lost the exclamation. There it is. Beautiful. Okay. And waha. Okay. So, trial 1, trial 2, trial 3. If we want to get rid of the Cl2, if we want to get rid of that y, all we have to do is pick 2 trials in which Cl2 does not change. So, and we're running out of room here. Let's go over here. And we got an E there. Okay, so we're going to pick the 2 trials in which Cl2 does not change. So I look at my 3 trials, and I go down the list, and I have to pick the 2 trials in which the chlorine, the Cl2, does not change. And that is trial 1 and trial 2. If we can cancel this out because they're exactly the same, then this whole variable goes bye-bye. So now we're just going to make a ratio. And what we're going to do is we're basically going to put one rate law over the other rate law. Now, to make it easy for yourself, always pick the higher rate and divide it by the lower rate. This is just going to help you out in the end when we're starting to do the actual math. So since we have to pick trial 1 and 2, I look at my rate values just to see which one is higher and which one is lower. Trial 2 has a higher rate than trial 1, so what I'm going to do is I'm going to put trial 2 over trial 1. And now I'm going to use all my trial 2 values for the rate law, and then I'm going to divide that by trial 1's rate law. So I'm going to use this formula to plug in the values that I know. So for trial 2, the rate was 4.56, and this equals a rate constant. We do not know the rate constant. They didn't tell us that, so I'm just going to leave it as K. Times by the coefficients. not times by the coefficients, times by the concentrations of trial 2. NO was 1. And Cl2 for trial 2 was 0.5. And now we plug in those variables, right? The NO was raised to the x, and the Cl2 was raised to the y. Now we're going to do the same thing for trial 1. So for trial 1, the rate was 1.14. This equals the rate constant. We still don't know it, so I'm just going to say K. Times by the concentration of the reactants for trial 1. So we have 0.5 and 0.5, and then it's raised to the x and the y. So now we start canceling things out that we can. It's cool that we don't know the K value because, even though we don't know it, if I have the same value on the top and the bottom, it's a constant. That goes bye-bye. And 0.5 y raised to the y divided by 0.5 raised to the y. All of this goes bye-bye. That's why we pick 2 trials in which the Cl2 didn't change, because you just cancel it right out. So now we're down to just dividing by the rate and dividing by the concentration for NO. So 4.56 divided by 1.14 is 4. So maybe I'll put 4 equals 1 divided by 0.5 is going to be 2. But, you could always just plug it in, just to kind of have it up on the screen. And this is simplified by just saying raised to the x. So now you say to yourself, 2 to the what will get me 4? Yeah, you got it. X equals 2, right? I have 2 2's. 2 times 2 is 4. I got 2 2's. That's raised to the second. Okay, so I found out one piece of the puzzle. I know now that this exponent is going to be a 2. So now we have to do the same thing to find out the Cl2. So what I'm going to do actually is I'm going to do this way, because now we're going to be doing number 2. Instead of solving for the x, now we're going to solve for the y. So that's the Cl2, right? So we have Cl2, and we want to solve for it, so that's the y. So it's basically the complete opposite. So instead, we now need to get rid of, you got it, the NO, right? So we want to pick 2 trials in which the NO does not change. So it's basically the exact same thing, but you're just flipping it. So I go back to my chart, and I see that, let's see, for the NO, pick 2 trials in which NO does not change, and it's trial 2 and 3. So higher rate over the lower rate, is it going to be 2 over 3 or 3 over 2? I look over here, and 9 is definitely greater than 4, so we're going to do trial 3 over trial 2. So trial 3 divided by trial 2. Okay, so use the same rate law, and to make it easy for yourself, you don't have to, plug in a 2 here if you don't want to. You can just go back to, the x values. So for trial 3, we have 9.12 equals the K times the concentration of these 2 guys. And for trial 3, NO was 1.00 and the other one was 1.00. They were both raised to the x and the y's. And then, just going to kind of streamline this, trial 2 is 4.56 equals, plug in these already because I got the color. Going to times by K, it's raised to the x and the y, and now we just plug in the numbers. So trial 2, I have 1.0 for NO and then 0.50. Okay, so same thing goes for what we did before. K divided by K Get out of here, right? And these guys, 1 raised to the x divided by 1 raised to the x, that goes bye-bye. So now you have these two values. 9.12 divided by 4.56, you get 2 equals 1 divided by 0.5 is 2, and that's going to be raised to the y. So you say to yourself, 2 to the what will get you 2? Yeah, you got it. Y now equals 1. And voila, we have found the y value. So this is raised to the first. So let's pause a minute because I have to erase this lovely work to go on to the next question, because we're going to now get the rate law and then we're going to answer what's the rate constant. So I'm just going to get rid of all of this, unfortunately. But it's got to go. Okay, goodbye. And now we are set because here was our rate law, right? And now we know what the x and the y was. The x was a 2 and the y was a 1. So all we have to do now is just plug in those values. This is raised to the second and this is raised to the first. And that is it. So this is the answer to the first part. What's the rate law? It's rate equals K times the concentration raised to the second times Cl2 raised to the first. The concentration of NO raised to the second times the concentration of Cl2 raised to the first. And in this case, I just want to point out that they did follow the coefficients. There was a 2 in front of here, it was raised to the second. There was a 1 in front of here, that's raised to the first. However, this is not always the case. If they wanted to be a little bit mean and a little bit tricky, they would have changed them on you, just to make sure that you know that you're doing the trials and not the coefficients. Now the next part is we want to find the rate constant. So, keep in mind that the rate constant is K. And we can't find out the rate constant unless we have the full rate law. So that's why, if they're asking for the rate constant, you have to make sure that you have the rate law first. So even if this was not even in the picture, right? Let's pretend that they gave you a chart and then they went straight to what is the rate constant. Boo-hoo, you still have to do that thing that we just did. And I've seen that on some tests, that they'll completely bypass this question and just ask you for what's the rate constant. You still have to do that process anyway, because you got to get those exponents. So now we got 3 trials. This is kind of teacher or professor specific. Some teachers, when they ask you to find the rate constant, they want you to find the K value for each trial and then average them. I've seen sometimes that, the last trial is always used. Generally speaking, if you do use any trial, 1, 2, or 3, your constant should be very close to, all the trials. I'm just going to pick a trial. You could pick a different trial and see if our K values are very similar. So I'm going to pick trial 3. So what I'm going to do is basically we throw in all the values now into the rate law that we know, and then solve for K. So for us, using the rate law, the rate was 9.12 equals the K value times the concentration of, let's see, we have for trial 3, 1.00 and then 1.00. We're going to raise the first one to the second and the first one to the first, the Cl2 to the 1. Now we just solve, right? 9.12 equals K. And now we can do all of this math, but 1 raised to the second is 1. 1 to the first is 1. And 1 times 1 is 1. So, we could say that this whole thing is 1, but basically, we found out what that K value was. K equals 9.12. And I just like to put it, I always like to have the variable on the left and the number on the right. Now the thing here is that we need to know the units for K. Now this is where it gets a little tricky because depending on your overall order, that's where your K values are going to change. So in order to find the units for K, you should generally know the overall order. Now the overall order is the sum, literally overall, just take the sum of all of your orders, which are your exponents. So I have a 2 and I have a 1 in my rate law, right? 2 and a 1. So in this case, my overall order would be 2 plus 1, and my overall order would be 3. From that information, depending on whether you get a 0 for your overall order, a 1, a 2, a 3, that's going to change the units for the K value. And what I'm going to say is that if you have an overall order of 3, it's probably easier to memorize your different units for K instead of always, plugging in units and kind of, canceling stuff out. So for an overall order of 3, your K value is always going to be a molarity to the -2 time to the -1. Tim unit. So always for a third overall order, the K value, if you're taking molarities, which we are, moles over liters is molarity, right? And I do see, I don't know why they put liter to the first here and then nothing here, but it's still molarity. But it's going to be molarity to the -2 or and time raised to the first. So just be careful on what time they give you. Molarity is going to be the same. And now the time that they gave us, we look for the rate, it's in H. H stands for hours. So I could say hour, HR, or you could just put H, it doesn't matter, to the -1. And that is the final answer to the K value. Okay? Now, the last piece of the puzzle, it said, what are the orders with respect to each reactant? This just basically means what's the order for the specific reactant. So for NO, we have NO and we have Cl2. Whoop. So we have to find out the order for NO and the order for Cl2. This is just the exponents that we found. So we already found these answers. The order for NO is raised to the second, so that's second order. The order for Cl2, it was raised to the first, so that's first order. And those are your orders with respect to each reactant. So if they ask you with respect to, all you got to do is just, take each reactant and say what's the specific order. If they ask for the overall order, you just add these up, just like we did, to get the rate constant units. And that's it. What did you think? I hope this helped. This one was crazy, but maybe 90% certain that this type of question you'll definitely see on a test or a quiz. Very common, so just watch out for those tables, okay? All right. I hope this helped you out. Let me know in the comments. And if you want to help us out, please hit the subscribe button. Thank you, thank you, thank you. And I hope you're having a great day, okay? I will talk to you soon. And I'll see you then. Bye-bye.